Problem 1, points A and B are on opposite sides of the Grand Canyon. Point C is 200 yards away from point A, and angle B measures 87 degrees, and angle C measures 67 degrees. What is the distance from A to B? Well, here they give you two angles of the triangle, so my first step is always to try to figure out what the third angle is. So I'm going to add those up and subtract from 180. And it looks like here the other angle is going to turn out to be 26 degrees. So as I go through my checklist of trig rules, SOHCAHTOA, you need to be given a 90-degree angle. And here we're not. We have a 26, a 67, and a 87. So next we look to use the law of sines. To use the law of sines, we need a matching set of side angles. And here it looks like we do have that because we're given angle B and we're given side B. So here my B's are my matching set, so I'm going to use the law of sines. And here they want us to find side C. So here we're going to write little c over the sine of angle C. Now that equals my matching set, little b over the sine of angle B. So here we're going to have little c, which is x, over the sine of angle C, so the sine of 67. That equals little b, so that's going to be 2,000 over the sine of angle B, here over the sine of 87. So I'm going to cross multiply. Here I'm going to have x times the sine of 87. That equals 2,000 times the sine of 67. And to solve for x, I'm going to divide both sides by the sine of 87 degrees. So here the distance from A to B can be found by doing 2,000 times the sine of 67 and dividing that by the sine of 87. So here, 1843.5. Two observers are standing on a shore a half a mile apart at points A and B. So I'm going to label that distance as half a mile. And it says they measure the angle to a sailboat at point C at the same time. Angle A is 63 degrees, angle B is 56 degrees. Find the distance from each observer to the sailboat. So we have to find the distance from A to the sailboat, which is C, and we have to find the distance from B to the sailboat. So we have to find these two distances. So here in this triangle, they're giving you two of the angles, so my first step is always to find the third angle by adding up the 2 and subtracting from 180. So here it turns out the third angle is 61 degrees. And now we have to go about finding both x and y. So let me start off by finding x. And first I look to use SOHCAHTOA. I look to see if there's a 90-degree angle, but here there's not. In order to use the law of sines, you need to be given one matching set of side angles. And in order to use the law of cosines, there's two scenarios. Either you're given two sides and the angle between, or you're given all three sides. So this is your checklist of which trig rule to use for these word problems. And here it looks like this is going to be an example of the law of sines, because here you're given a matching set. Here you have angle C, or else we actually found angle C, and here we have side C. So here we're given a matching set, the C's, so we're going to use the law of sines. Now first I'm solving for x, and x is the side opposite angle B, So here I'm going to be solving for little b. So here I'm going to go little b over the sine of angle b. That equals, now my matching set, my c's. Little c over the sine of angle c. So I'm going to substitute in little b, which I called x, over the sine of angle b, so that's the sine of 56. That equals little c, which the side opposite angle c, the side opposite the sailboat, is half a mile, over the sine of angle c, so here it's going to be the sine of 61 degrees. So here we're using the law of cosines. We're not going to make a big deal that this is a half. We'll just go about doing our math. So here we're going to have x times the sine of 61. That equals 1/2 times the sine of 56. And in order to solve for x, I'm going to divide both sides by the sine of 61. So here on my calculator, I'm going to go 1/2 or 0.5, either one, times the sine of 56 divided by the sine of 61. So here I got my answer. I either did 0.5 times the sine of 56, or you can even do a fraction over a fraction on your calculator. So here's your answer, and normally we go to the nearest tenth, but here, since they gave you the half a mile, maybe what we'll do is we'll go to 3 decimals, just so you can kind of see the difference between these distances to the ship. Normally, though, we would round to the nearest tenth. So here, the distance from observer A to the ship is 0.474. So that's the distance for letter X. Now we have to go back and solve for Y. So I'm going to fill in on my diagram X is 0.474. And then now to find side Y, which is the side opposite angle A, I still have that matching set. I still have my C's. I actually have another matching set. I have my B's. So I can either go about finding side A for Y on my diagram by the law of sines, because I have now 2 matching sets, or now I have 2 sides. Here I have this side, which is side B, this side, which is side C, and I have the angle 63 that's in between. So here I can either go about solving for Y by either using the law of sines or the law of cosines, and I'll show you both ways. Here, to use the law of sines, I'm solving for the side opposite angle A, so I'm going to go little a over the sine of angle A. That equals, now you can either use your B's or your C's. I'm going to use my C's because I'm using the most given information. So here I'm going to go little c over the sine of angle C. So here I'm going to have little a, which is Y, over the sine of angle A, which is 63. That equals little c, which is a half a mile, divided by the sine of angle C, so the sine of 61. So here, if I want to go about solving that side by the law of sines, I'm going to have Y times the sine of 61. That equals 1/2 times the sine of 63. So here, to solve for Y, I can divide both sides by the sine of 61. So on your calculator, you could do this expression, 1/2 or 0.5 times the sine of 63 over the sine of 61. However, if you prefer to use the law of cosines, and I do, even though it looks more intimidating, it's less algebra, it's less solving and cross-multiplying. Here I want to find side A, so I'm going to write a squared equals b squared plus c squared minus 2bc times the cosine of A. Make sure that whatever side you're solving for, that's the angle that you're using. So here we're going to have, if I'm solving this by the law of cosines, a squared, so that's just y squared, that equals b squared, so that's the side opposite angle B, so that's the 0.474 squared, plus c squared, well that's the half a mile, so plus 1/2 squared, minus 2 times 0.474 times a half, times the cosine of angle A, which they told you in the problem was 61. So you can either, to get your other side, use the law of sines and type in this fraction, or you can use the law of cosines and enter in this entire right-hand side and then take the square root of that, because that's y squared. So here are the two acceptable answers for this question. If you use the law of sines, your answer to 3 decimal places is 0.509. Here, if you use the law of cosines, the acceptable answer would be 0.495. Why is there two acceptable answers? Well, when you deal with trigonometry, you are rounding off. Here, to get the 0.474, we rounded off. So you're getting answers that are not exactly to the nearest decimal place correct. But if you round these each to miles, you're dealing with about a half a mile for each. A person at point A looks due east. So here are our directions: north, south, east is to the right, and west is to the left. So we have a person at point A is looking east, so he's looking to the right. So there's point A. The person is looking to the right. They see this UFO with an angle of elevation of 40 degrees. At the same instant, another person 1.0 miles due west of point A. So point A, we have to go west. We have to go to the left. So a person is 1 mile due west at point B, and they sight the same UFO with an angle of elevation of 25 degrees. Find the distance between A and the UFO. So the distance between A and the UFO is this green line there. Call that X. How far is the UFO above the ground? So I'll have to draw a line segment going down, and that's going to be Y. So this is our diagram that we need to have for this particular question. Well, what I'm going to do is I'm going to throw in some other letters up here. Maybe I'll call the UFO point U, and then I have points B and A. Maybe I'll call this point down here, that's on the ground, maybe I'll call that point G. And the first question is asking us to find this green line segment where X is labeled. And that is actually in two different triangles. It's in this right triangle here. It's in triangle UAG, and it's also that line segment in triangle UBA. And I have to try to figure out which triangle I want to use to solve for X. And if you look at this right triangle, this black triangle here, I only know angles. I only know 40 degrees and a right angle. I could figure out this angle here, because 40 plus 90 is going to be equal to 130, and then 180 minus 130, that's going to be equal to 50. So I know this angle in the black triangle is 50 degrees, but I don't know any of the sides. So instead, to figure out what X is, I'm going to have to use this green triangle, which here I call triangle BAU, because I know this line segment is 1, I know this angle is 25, and here is where my X is going to be. Now, do I know anything else in this green triangle? And the answer is yes. I know that this line segment below, I know these two angles, 40 and this obtuse angle, they form a straight line. So I know that has to add up to 180. So if I go 180 minus 40, I know this angle of the green triangle is 140 degrees, because this 140 and the 40 degrees in that black triangle have to add up to 180. So I'm going to be using this green triangle to solve for X. And now I'll go through my checklist. Is this an example of SOHCAHTOA? Do I see a 90-degree angle? And the answer is no. I have 140, I have 25, so they add up to 165. And then if I go 180 minus 165, that gives me 15 for this skinny little angle up top there. So I don't have a 90-degree angle, which means I'm not going to be using SOHCAHTOA. Next, I'll try to use the law of sines to see if I have a matching set of side angles. And here, I think I do. If you look at angle and side U, here I'm given angle U is 15, or actually I figured out that that was 15. And then I know side U, I know little u down there is going to be equal to 1. So I do have a matching set. I have the u's, and here I want to go about finding x, which is actually opposite angle B. Because I have angle B, and that would be side B. So here I'm going to be using the u's and the b's and the law of sines to solve for x. So here I'm going to solve for little b, so I'm going to have little b over the sine of angle B. That equals now my matching sets, my u's, little u over the sine of angle U. So I'll substitute in. Here I'm going to have little b, that's what I'm solving for, I called that x, over the sine of angle B, well here the sine of 25 degrees. That equals little u, so the side opposite angle U, which is that 1, the distance between those two people. So u is 1. And then over the sine of angle U, here that's going to be the sine of 15 degrees. So this is going to be the equation I'm going to use to solve for x. I'll cross multiply x times the sine of 15. That equals 1 times the sine of 25. And then here to solve for x, I'll divide both sides by the sine of 15 degrees. So here, x in that diagram, the distance between the person at point A and the UFO is 1 times the sine of 25, so you really don't even have to type in the 1, over the sine of 15. So here, x is going to be equal to 1.6. So now, we're going to go about finding y. Now, y is a side of this smaller black right triangle. It's also a side of the big triangle itself. And which of the two triangles should we try to use? Well, this big red triangle that I'm outlining right now, we only know a piece of a side. We know from A to B is 1, but we don't know the entire bottom. We don't know this entire hypotenuse, and here we're trying to find the height. So that big red triangle is not going to be helpful. Here I'm going to use this smaller right triangle, which I'm going to reproduce over here. Y is what I'm solving for. I have a right angle. I know this angle was 40. I know this angle was 50. And we figured out that x, the hypotenuse, was 1.6. So now if I go through my checklist, are we going to be using SOHCAHTOA, or are we going to be dealing with a right angle? And the answer is yes, we do have a right angle. We're trying to figure out the height of the UFO. So here, my angle, and I have two. I have 40 and I have 50. I'll use the 40 because that was given to me. The angle is 40. If I label the hypotenuse, here the hypotenuse is 1.6. And here I'm trying to solve for y, and y is opposite the angle that I'm using. I'm using angle 40, and y is going to be opposite that. If you use angle 50, then y is going to be adjacent to it. But here I'm using the angle which is 40, and that's going to be the opposite. So here I'm going to be using sine because I have the hypotenuse and I have the opposite. So here I know the sine of an angle equals opposite over hypotenuse. So the sine of the angle is 40. That equals the opposite, which is y, over the hypotenuse, which is 1.6. Here, since what I'm solving for is in the numerator, I'm going to put the sine of 40 over 1 and cross multiply. If the y would have been in the denominator, I would have had to use the switcheroo rule. But here I'm not, because y is in the numerator. So I have 1 times y, which is y. That equals 1.6 times the sine of 40. So if I do that on my calculator, I'll get the actual height of this UFO. And since it's the side of a triangle, we're going to round to the nearest tenth, which looks like here it's going to be 1.0. So this UFO is 1.0 miles off the ground.